In this video, we will search, sort and paginate using Kotlin Spring Boot with MongoDB. Before we start building the app, I would like to remind you that this video can be combined with other videos. So if you want to use Kotlin with any of these front-end frameworks or with MySQL or MongoDB, I provided some links in the description of this video. If you don't want to combine them, don't worry, you can watch this video till the end. Also, make sure to check scalablescripts.com. Now let's start building the app. Now let's create the app. Go to start.spring.io and here we will generate our project. So my project will be a Maven project. I'll select Kotlin here, Spring Boot the latest one, and the metadata here. I'll put the scalable scripts here. And this is Kotlin search. Lazy loading, search and sorting. And the Java version will be 16. Now let's add the dependencies. So we need Spring Web and also MongoDB. Spring Data MongoDB. And that's it. So now let's generate. Now let's open the project. I'm using IntelliJ IDEA Ultimate. There is a 30-day free trial. So this is the project. I will make some changes. I will remove the test files here. And I will remove these folders in the resources. And this is our main file here. And now let's add the necessary configuration. So first I will create here a Kotlin file. I'll call it web config. This class I will extend it with web MVC configurer. I'll add the decorators here configuration. And also enable web MVC. So why do we need this class? We need this class to enable cores, since this app can be used with other frontends. So we'll override here function add course mapping, and so this is correct. So I'll remove this. So before I add any code here, what is course? So course is cross-origin resource sharing, and our app will run on a different port than the frontend. This app will run on port 8000 and the frontend can run on a different port. And with this, the browser will prevent that, and we don't want that. So we want the frontend to use the backend. So the registry, add mapping. The mapping will be this mapping, and we'll add the allowed origins. So the allowed origins will be HTTP localhost port 3000. This is for React. And 8080 is for Vue, and 4200 is for Angular. So you can use all the frontends with this app. So that's it. This is our course mapping, and it is enabled automatically. Now let's add the application properties, and I will paste them here. So the port that our app will start will be 8000. I will use a localhost for my MongoDB connection. This will be the database. I will call it Kotlin search, and this will auto create our repositories. And now let's connect to our database. So I'll connect to my local MongoDB database. So I will just test the connection and type OK here. So I connected with MongoDB. I don't have any database yet. We need to create it. But first, let's run the app. We can start our app now. So I will run this project. And if everything is correct, then we connect with our database. So till now, everything is correct. And we can go to localhost port 8000 and we have a white label error page here, which is not actually an error page. This means that we don't have any endpoints yet. So everything is successful. Now let's add the products for our database. So here I will add a new package called models. And inside the models, I will create a Kotlin file called product. So we need to map this class to a document. So let's add this as a document here. And let's add the columns for this product. So var id is equal to an empty string here. We need the title, empty string. So I'll copy this. This is a description. This is a image. And the last one is the price, which I will initialize it with 0. And we need also to add a decorator for the ID here, which is an ID. So with this, MongoDB will auto-generate the ID. Now we created the product, we can create also our controllers. So I'll create a package here, controllers, and inside I will create the product controller. This will be a REST controller, and we need to add a prefix here. So request mapping will be API here. So this will be the prefix for all of our endpoints here. And we need to add our first endpoint, which is the Frontend Endpoint. This will be a request mapping here, a get request, not request mapping, it will be a get mapping. And this will be a get request to API/products/frontend. And here we want to return all the products, but to return here the products, we have to get the repository. So let's create a repository. So I'll create a package here, repositories, and inside I'll create the this will be an interface, this will be a product repository. So we got the interface product repository. Now we need to extend this interface with Mongo repository. And this will accept two parameters here, the product and the ID, which will be an, I'll put it an int here, or can be a string. And that's it. Now Mongo repository will give a lot of function to the product repository, and we can inject it here. So in the product controller, I will add open brackets here, and this will get the private val product repository here, as a product repository. So this is a dependency injection here when we inject something in the controller. Now that we got the repository, so what is error here? So this doesn't matter. We will return here response entity. Okay, so this will be a normal response, and we will call here this product repository. So we can see that we have a lot of options here. We want find all, and we will return all the products here. We need also the return type for this function, which is a response entity. This will return a list of products. And that's it. So with this, we got our first endpoint, which returns all the products. And let's run again this app. Now let's test this endpoint. To test the endpoint, I will use Postman, so make sure to download and install Postman. So I will open it and I will send a GET request to HTTP port localhost /API/product/frontend. So Postman helps me. This is the endpoint. Let's send the request. And as expected, we are returning an empty array because we don't have any data in the database. So to get data from the database, we have to add here a seeder. So I will create a package seeders, and I will add here a Kotlin class data seeder. And this data seeder will extend from application runner. And we need to implement some members from application runner. So implement members, we need to override the function run here. And with this function, it will run in the beginning. So let's make this also a component here. So this application runner will run immediately when we restart our server. And what we want to do here, I will add a for loop and I will create 50 products. So this for loop will be the index will be in the loop 1 to 50. So like this. So this I will contain 1 till 50. And let's create our product here. So we'll create the product which is equal to product. Now let's set the title. So product.title is equal to title disease plus I. Then we have to set the description like this also. So for the description, I will use I+1 here because I will show you later why the title is one less than the description. So this is for search purposes because we will search this product. So let's make a distinguish for these values. Product.image, this will be HTTP lorem pixel.com 200 like this question mark, and we need a random integer here. So random next int from 10,000. So don't forget also to import Kotlin random here. So this will be a random integer until 10,000, and the last one is a price, which is product. Price is equal to random next int from 10 to 100. So with this we got the product. Now we need to inject here as a dependency the product repository again. So private val product repository. We got the product repository and we will call it this product repository, save the product, and that's it. With this we will create all the products that we want. So let's run again. And now our app is running, and we can create these products in our database. So let's refresh our database. We can see from 23 to 24 tables. I will search for Kotlin search. And our database now has the product entity, the product document that we wanted, and has all the columns that we need. So also it has 20 products, not sure why 20, because I inserted 50 here, but it doesn't matter. So this is how we seed products, and I don't want to run this command again, and I will uncomment this. So for the moment I will comment also the component here, because we don't want to seed again, but our endpoint now, something to clarify here, the IDs will look numeric, which is weird because I'm reusing the content from my other video using MySQL. So don't worry, everything will work the same, but with MongoDB just the ID will change and every functionality will be the same. We will get all the values. So this is our front-end endpoint. Now let's add the other endpoint, which is the backend endpoint. So I'll copy this, paste it here, and this will be a backend endpoint, and this will be backend here. So we got the backend endpoint, and this will work the same as the frontend. So backend here. Why is not found? I forgot to rerun the server. So this works the same. Now we want to add the search for this backend. So we want to add here question mark search is equal to something, and we want to filter these products. So to do that we have to add a custom search for our product repository. Here we will add the function, I'll call it search, and this will accept a search value as a string, and the return value will be a list of products. So that's it for the function, but we want to make here a custom query. So we have to add here a decorator query, and the query that we want to add is we want the title and the description to contain this search string. So for that I'll do it only for the title in the beginning. So I'll add here curly braces. Inside I'll put the title with the quotes, and for the title to contain this search string I will open another JSON object here, and we will use a regular expression regex. now it's having an error about this $sign because with this we can use variables in Kotlin, so we need to escape this. So I will do it like this. So this is how MongoDB accepts regular expressions, and regex we will use the value, which is this search value that we got here, and that value can be used like this, question mark 0. So that's it for this value. We need to add also the options, also with the $sign. So escape dollar options I. So this is the command that this is a query that we want to send to MongoDB in order to search products with this value. So now let's use it to our product controller. So here we need to pass the search value, which we will get it from the params here. So we will add here request param s here will be search as a string. So like this is our param that we want. Also, I will add another option here. If we don't set the search param, I will add the default value to be an empty string. So this is also important because it will throw an error if we don't add the search param. And in the end, we got the search, and I will replace this find all with a search, and I will pass this search there. And that's it. It's that simple. Let's rerun this up. So everything is correct, and now we can search. We can add a question mark here. Search is equal to this is 1, or I will put it here. So this is 1. Let's remove this. So this is the actual value, and we can see that we are getting the title. This is 1 and 10, 11, 15. So this works fine. This is working as it should. But as I said, we'll search also for the description now. And if I search now, we can see that we're getting title 9 here and the description like this. So we know for sure here that we are searching with the description. So this is how it works. So we added the search. Now we want to sort these products based on the other parameter, which is the sort. So sort here, and this is sort. And to sort this, Spring Boot makes it really simple. In our search here, we can add a variable sort as a sort. So don't forget to import the sort from this import here. And what this does is we can automatically sort this result if we create a variable. So I'll create a variable here, direction. So because sort is taken, so I will call it direction is equal to sort unsorted. So by default the direction will be unsorted, and I will pass the direction here. So just like this, we didn't do anything with this, so this will work the same. But now depends what variable sort we send from the front end. So if the sort is equal to ascending, then the direction will change. So the direction will be sort by sort direction ascending, and here we need the value, which is the price in the product's case. So this is a direction if the sort is ascending. If it is descending, so else if sort is equal to descending, the direction will be descending here. So we added the sort, and now we can sort. So I will remove this search here. We can add here sort ascending, and of course we need to restart. So we'll see that the order is changed. So the first item is a price of 14, 15, 18, etc. So they are sorted in ascending order. Also, we can sort in descending order. Price 99, 94, 93, etc. So we can also search and sort. So we can see that we have less items and we are sorting. So this is how we search and we sort. And now the last part is to add the pagination, which Spring Boot makes it also really easy. So for the pagination, we need to add the page here, where the default value is 1 and the page will be an integer here. So we added the page. Now for the pagination, it's also super simple, because we can also paginate and sort at the same time by changing this variable to pageable, as type pageable. So I will remove the sort, and now that I changed the value from sort to pageable, how do we insert the sort there? This is really easy. So we will change this value to pageable. No, page request of. We need the page. So where are we starting? So we have the page here as an integer, and this starts from 0. So the beginning in our logic is 1, but this starts from 0. So we have to use here page minus 1. We need how many items per page we need. So create a val here, per page is equal to 9. We want 9 items per page, and I'll pass here per page. And the last value will be our direction here. So with this we can also paginate, and we can also sort. So this will clear everything. If I save and I will rerun, we can send this request. So I will remove this here, and we will get our first 9 items here. So this is working fine. Also, I will change a little bit the structure here. I will create a directory, DTOs, and this I will create here a class which is paginated response. This class will return the response like this. So inside the constructor here, we'll get the data as a list of any. We will get the total of the items. This is an integer. We'll get the page. This is also an integer, and we will get also the last page, which is also an integer. So this is the response that we want to return from this request, and I'll cut this. So I need also one more, and this will return a paginated response where the data is equal to this. I'll change the response type here to any, and now the paginated response needs other values. So the first one is the total. So the total, we need another query to find the total of the products because now we paginate them. So I will go to the search. Here I will copy this and I will paste it again, and I will create another function. I will call it count search. So this will be similar. I will remove the pageable here, and this will return an integer. So to count this query, we have to add an option here, count is equal to true. And that's it. So this other query can help us know the total of the products. So we can use it now here. And the total is equal now to this product repository count search. We'll pass the search string here, and we got the total. And the total will be passed here. The page will also be passed here, and we need the last page. And we need the last page. We have to calculate it is the total divided by per page, and that's it. This is the response that we need. So this will return, we need to restart. Let's send the request, and we are paginating, and we get the total here, page 1, last page is 5. Now we can send the next page, send the request, and we are at the next page. So this is how we paginate, we search, and we sort. So now the total has changed, page is 2, last page is 1. So this is probably wrong. Maybe we need to add it like this. So this is total divided by per page plus 1. So like this it will work for sure, because in the second page we have more items. So this is how we search, sort, and paginate using Kotlin Spring Boot with MySQL. I hope you liked this tutorial, and if you did, please also share and subscribe. Thank you.